picture tube, electrons are ejected from the cathode with negligible speed and reach a velocity of 5 into 10 to the power 6 meters per second in traveling 1 centimeter. Assuming straight line motion, find the constant force exerted on the electron. So the way we can approach this is, first let's find the acceleration it will take for this electron to go from 0, it's at 0 meters per second, and within 1 centimeter, it reaches a velocity of 5 into 10 to the power 6 meters per second. What's the acceleration involved here? Well, we can use the formula v squared minus u squared equals 2as. V is the final velocity. In this case, that's equal to 5 into 10 to the power 6 of that squared. U, since it's negligible speed, you can just take it to be 0 and you don't need to write it. So negative 0 is equal to 2 times, well, what is A? A is something that we don't know about, and S is 1 centimeter. 1 centimeter. Now we can write this 1 centimeter as in meters, so that will be 1 into 10 to the power negative 2 meters to make everything in SI units. And here the units would have been meters squared per second squared. Now what you can do is you can take this to the other side and you will get, if you solve this, you get 25 into 10 to the power 12 meters squared per second squared. That divided by 2 into 10 to the power negative 2 meters. That is equal to the acceleration. And if you do a bit of arithmetic, you arrive at 12.5 into 10 to the power 14 meters per second squared. That's the acceleration. To even refine it, you can write this as 1.25 into 10 to the power 15 meters per second squared, just to make everything in scientific notation. And now you need to find the constant force. Well, to find the constant force, you need to multiply the mass times the acceleration. You now know what the acceleration is. The mass is given to be equal to 9.1 into 10 to the power negative 31. And so you just need to multiply this by 9.1 into 10 to the power negative 31 kgs. And this multiplied by this gives you kg meters per second squared. That's just Newton. So newtons is the unit that we will get. And then 10 to the power negative 31 times 10 to the power 15 gives you 10 to the power negative 16. 9.1 into 1.25. You can work that out. It will be somewhere, it will be equal to 1.11.9, I guess. That will be the correct value. That will be equal to 11.9. And once you have done this, once you have actually calculated what this will be equal to, I guess that will be a 10 there, not a 9, not 11. That will be 10.9. But anyways, you can just write this in a more sort of compact scientific form, and you would just shift this decimal place here. You would get 1.09 to 10 to the power negative 15 newtons. Since you shift it 1 to this side, you add 1 here, and you can approximate this to be equal to 1.1 into 10 to the power negative 15 newtons.